Ninja Warriors, welcome to yet another power packed session. And today's session is last lecture of ROAR series. So I guess approximately 40 lectures are done in ROAR series. This is the 40th. This marks the 40th lecture of ROAR series, and it is giving me mixed feeling. It is making me emotional. It is making me excited also about the brand new series. So yeah, I mean, it's been a long journey. It's been it's been an intense journey. So on this note, we are going to start probability. I hope that you will watch this lecture with your utmost dedication and without distraction, because in probability we are going to tackle lots of things, all the concepts. Definitely, I don't need to tell you. In every road series, we are doing that. All the concepts will be covered. Number one. Number two, PYQs. We will do a lot of PYQs in this session. But along with that, we will do a non-PYQ questions as well, because it is very important to build the basics of any chapter. And you can't just read the theory and directly go towards the PYQs. That will create a sense, a feeling of anxiety in you that, okay ma'am, theory I'm getting, and but questions direct I'm not getting. So we have to fill the gap with basic questions so that you understand what the probability chapter is. Okay, so this is how we all should study. That, okay, theory we have studied, then we have to clear the concepts and then jump on to the PYQs so that we are absolutely ready for them. We don't just get into war space without weapons, right? If I'm telling you have to go on the war, and if I just tell you go without weapons, it would be stupid, right? So yes, on this note, if you understand what I'm trying to say, let's start probability. And in probability, what we are going to, first of all, we are going to understand some terminologies. Okay, all right. So first, spare first 10 to 15 minutes so that I'll be able to explain you all the terms. So whenever we study the main concepts, so that you don't become like this, oh, I don't know this term, I don't know this term. Okay, so first 15 minutes will be understanding of all the terms related to probability chapter, and the very first term is random experiment. Okay, so what is a random experiment? And today I'm not going to use any slide, all will be handwritten. Random experiment. Okay, I just want to also, one more feedback I just want to know that I know that visually it looks beautiful when I take slides and everything, but what I feel is if I write each and everything over here without the slides, then I feel that it makes the concept more stronger, because when I am writing, everything is going into the print. When it is already written, then I think a little less. Obviously questions, so we have to write in the slides format, but the theory part, feedback in the comment section. Okay, all right. So random experiment, what is a random experiment? Random experiment is something which results in fixed output. Okay, all right. So random experiments, for example, throwing a dice. Okay, so or tossing a coin. Now tossing a coin may, are you able to predict the outcome? Tossing a coin. Okay, so outcome is predictable. Either you will get a head or you will get a tail. That means you know the outcome. Random experiment is something that, although the name is random, but the outcomes are not random. Although they are random, but it is still predictable. That's what the agenda is. Throwing a dice, that means we can predict it. It is not something that we don't know what is gonna happen. Throwing a dice. Okay, so throwing a dice, you know, either outcome will be 1 or 2 or 3 or 4 or 5 or 6. Okay, so this is what a random experiment in easy terms. Okay, so if I just want to write the definition, it is an experiment. Random experiment, it is an experiment, okay, which results in outcomes. First of all, which results in outcome. Okay, which is one of the various possible outcomes that are known beforehand. Okay, which are various possible outcomes, which are various possible outcomes which you know beforehand. Okay, that's it. I think random experiment clear to you. Now the next definition is sample space. Okay, what is a sample space? Let me just write down sample space. Okay, all right. Now sample space is something, basically all the outcomes of random experiment. Okay, so set of all possible outcomes, set of all possible outcomes of random experiment. Suppose throwing a die. Just tell me, what is the possible outcome? Throwing a die. What is the possible outcome? So set is, sample space is S. You can get 1 or 2 or 3 or 4 or 5 or 6. That is your sample space. As simple as possible. Okay. Now, one question I would like to give you. Question. Just tell me, write the sample space. Write the sample space of experiment. Okay. And the experiment is, a coin is tossed. A coin is tossed. If it shows head, a coin is tossed again. Okay, a coin is tossed. If it a coin is tossed, and if it shows head, it is tossed again. It is tossed again. Okay. Else a die is thrown. Else a die or dice is thrown. Okay. So this is your experiment. You have to understand the experiment first. What is happening? See, a coin is tossed. So there is a coin. You can toss a coin. Two things are possible. Head or tail, obviously. Now the experiment says that a coin is tossed. If it shows head, then it is tossed again. So now if it shows head, then we have to toss it again. So again, after head, again two possibilities, whether it is head or tail. But if it shows tail, the first coin if I tossed, if it shows tail, so that means else case is here, a die is thrown. So after tail, you don't have to toss a coin. You have to throw a die. Okay. So after tail, if you do throw a die, what are the possible outcomes, ma'am? 1, 2, 3, 4, 5, 6. Okay. So what are the outcomes? Now sample space. Sample space is, first if you toss it, you can get a head. And if you get a head, you have to toss it again. So you can get a head or you can get a tail. So this is the first scenario. Now suppose if in the beginning you toss a coin, you don't get a head, you get a tail. Now you have to throw a die. So it is going to become T1, T2, T3, T4, T5, T6. This is how you think in probability. Easy peasy. This we have studied in previous grades as well. And now the another term, I hope sample space is clear. Another term is an event. Okay. Event is basically subset of sample space. Okay. Subset of sample space. Okay. Suppose, so first of all, a experiment is there. Random experiment. Then sample space will come into the picture. Okay. So suppose if your experiment, random experiment is throwing a dice. and sample space is 1, 2, 3, 4, 5, 6. Now event can be multiple. Suppose event A is getting an even number. Event A. Event B, getting an odd number. So event A will be having 2, 4, 6. Event B will be 1, 3, 5. It could be event C, and note it down that all the events will be subset of the sample space. So now event C can be getting just 1. That's it. Okay. So this is what is your event, getting number 1. Okay. So it will have just 1. Event can be anything. So this is your event. Okay. Alright. Now types of events. Okay. After this, we have to understand what are the types of events. Which color? Okay. Types of events. Number one is impossible and sure event. Okay, impossible and sure event. Impossible event. First, impossible event is getting a number 7 in a throw of die. Okay, so getting 7 in a throw of die. So getting 7, ma'am, die is only having 1, 2, 3, 4, 5, 6. 7 is not possible. So that means if I just mark it as event A, so A is a null set. A is not having, and by the way, it is still a subset of sample space. Okay. Alright. So this is impossible event. And if I just slightly tell you about the probability of an impossible event is 0. That we are going to again understand, but beforehand, because you know a little bit nitty-gritty about the probability, so I'm just letting you know this is impossible event. Now second one is sure event. Sure event means that it is going to happen for sure. Okay, so sure event is, suppose tossing a coin. This is a random experiment. Sample space, head, tail. Event. Now event A, sure event, if I just want that getting either head or tail. Okay, so just understand. Sure event, getting either head or tail. So A is also h, t, which is, by the way, again, A is subset of sample space, right? So clearly that A is a sure event and probability of this event will be 1. Definitely it is going to happen. Obviously, if I throw a die, if I toss a coin, either I will get head or I will get tail. Getting it? So this is impossible and sure event. Now simple event. Third is simple event. Simple and compound. See, simple event. Simple event is a just plain basic event, getting a head followed by tail in a throwing of coin twice. So suppose event, now your random experiment is random experiment. Random experiment is throwing a coin twice. Okay, so that means HH, TT, HT, TH. This is your sample space, right? Simple event means getting a just like it's just an event. Okay, it will have only single element. So event A will be getting 2 heads. That's it. Getting 2 heads. That means A is having h, h. That means A is having 1 element. Only 1 element of sample space. So this is a simple event. Okay. Now compound event. Compound event in something. See, compound event. Compound event is combination. Okay. So suppose again, getting even number in throwing a dice. Getting even number in throwing a dice. So now even numbers are multiple, so your sample space will be either 2 or 4 or 6. Just like that, this is a compound event. This is the fourth terminology. Okay, so compound event. More than one sample point you will see. Okay. Now fifth is complementary event. You know what is a complementary event? Complementary event is something, see, if suppose this is your event, right? This is A. From this, if I have to write A dash, getting an even number is an event. Now complementary to event A will be what? Getting an odd number. Okay, complement. Remember set theory. Getting an odd number will be complement. Odd number will be complement event in throwing a dice. Okay, complementary event, clear? Now we are going to talk about the algebra of events. Okay, algebra of events, again set theory, basic algebra of events, basic set theory we have to understand in this. Okay, so first like 15 to 20 minutes you have to understand that these are the basics of probability which we already know. Maybe we are just brushing up and we are just warming up for the actual probability. Okay, so first is A or B, or you can call it as A union B. Okay, so A or B, A union B, with the help of the Venn diagram it is like this space, this shaded space, A union B. Okay, either A or B. I don't have to explain it, either A or B. So basically okay, just tell me one thing. A is getting even number, B is getting odd number. Just tell me. A union B will be what? Getting either even or odd. So all the sample space 1, 2, 3, 4, 5, 6. This is how it is. So probability of A union B will be what? A union B is a sure event. Are you understanding? Either 1 we will get, or 2, or 3, or 4, or 5, or 6. So either of these 6 quantities I'm gonna get if I throw a dice, right? Throwing a dice, on single dice. Okay, so it is going to be 1. Not always. A union B is not 1, but in this case it is 1. Okay, although probability I have not introduced till now, but I'm just little telling you so that you just become aware of it. Okay, A or B, and then we are having A and B. Now suppose A and B, this is A intersection B. So again, if you have to draw the Venn diagram, it will represent by the middle thing. Okay, so suppose A is your getting 1 or 2 on a die. Okay, B event is getting even number on die. Now just tell me, what is A intersection B? So A intersection B will be just 2. Okay, alright. So if I just talk about the probability of A intersection B will be what? Favorable outcome upon total outcome. Favorable outcome will be what? This 2 upon total outcome will be 1, 2, 3, 4, 5, 6, 2 by 6. So this is 1. Sorry, not 2. It is 1. Favorable outcome is 1. We have only one element in A intersection B and we have 6 element in total sample space. So this is your probability. Okay, alright, I guess that this is clear. And now two very important definitions, very important for your JEE main and for your other competitive examinations as well. What are those? Okay, so those definitions are equally likely events. Okay, first, equally likely events. Equally likely events. Equally likely, the definition, the term also is very clear, very obvious, quite intuitive. Equally likely. That means, okay, events, okay, events having same chance of occurrence, having same chance of occurrence. Okay, just like that coin, unbiased coin. So getting ahead in tossing of a coin A, and event B is getting a tail in tossing a coin. Just tell me. Yes. So A and B both are equally likely. Okay, so if I just toss a coin, equal chances are there that I get a head or that I get a tail. That is why in cricket they use this technique, head and tail. They just don't randomly do anything because they know it is a fair thing, fair coin. They take a fair coin, they throw it, and then head comes, one team has to choose batting or bowling. Tail, the other team chooses for batting or bowling. Okay. Obviously, probability of A is equals to probability of B in the case of equally likely event. Okay. Alright. The next definition is mutually exclusive. Mutually, actually two, nahi, three. There are three very important definitions. How can I forget? Three important definitions. Mutually exclusive. This term you will understand using people coming on podcast na these days. So in podcast also this mutually exclusive, people who are good orators, mutually exclusive, they use this term a lot in reality shows, in podcast. Okay, so what is mutually exclusive events? So basically this is also known as disjoint events. Okay, so basically the intersection between two events is null. Okay, so suppose I take A, which is getting odd number on a die, and this is getting even number on a die. So obviously A is what? 135 and B is what? Tell me. 2, 4, 6. Correct? A and B. Okay? So A intersection B is null. Mutually exclusive is something. So this is about two events. There can be three events which are like not related to each other, right? So yeah, mutually exclusive. And third definition is mutually exhaustive. Mutually exhaustive. Okay. Mutually exhaustive events are, so suppose two events, okay, A and B. Again I'm gonna take the same again. Getting even number on a die, and odd number on a die. Okay. Now A is again 2, 4, 6 and B is 1, 3, 5. Now mutually exhaustive events means that the moment you combine those two events, you take union of those two events, what you are going to get is nothing but the complete sample space. That means A union B will give you complete sample space. Okay. Suppose I am a teacher. I go to a school and I want class 12th together, complete class 12th. And I have only two sections. Small school, not a big school, very small, less students suppose. So 12th science, one batch, 12th commerce, one batch. So I just want the combined 12th. So 12th science and 12th commerce, if I combine, will I get combined 12th? Yes. So 12th science and 12th commerce are mutually exhaustive events. Okay, but suppose I am in a school wherein 12th science, 12th commerce, 12th arts is there, and I want all the students of class 12th right here. So if I just say that 12th science and 12th commerce, are these mutually exhaustive? No. Because if you combine, are you getting the combined complete sample space? No, because art students are left out, right? So, but again, now this time, what are mutually exhaustive events, ma'am? Commerce students, science students and art students, if you combine them, then they will become, right? Okay, mutually exhaustive events are like that, okay? Mutually exhaustive events. So I guess I am done with the definition. Now we will talk about the classical definition of probability. Now here I introduce the probability. Now classical definition of probability that we have already studied in our previous grade. Let me just write it down. Classical definition of probability. Okay. Classical definition of probability. Alright. So again, suppose you are having a random experiment wherein event A is involved. Okay. Now event A is having number of elements in event A is cardinality of A. This is number of elements in event A. Okay, of a random experiment, this is cardinality of sample spaces, total number of elements in sample space, S. Sample space S. So now your probability formula is equal to what? Cardinality of A upon cardinality of S. I will also call it total number of favorable outcomes upon total outcomes. This is something favorable outcomes upon total outcomes. Favorable outcome upon total outcome. I am going to use it like pretty much in this whole lecture. Okay, clear? Okay, alright. Now let us take a note that probability of A complement will be equals to 1 minus probability of A. Just like, okay, because see, yeah, probability of A complement is 1 minus probability of A. So probability of occurrence of A, if you know, so this is probability of occurrence of A, right? So probability of non-occurrence of A, probability of non-occurrence of A. Okay, so this is the classical definition of probability that we have already studied in previous grades. Now here comes one question, and the question is, a fair die is thrown. A fair die is thrown. A fair die is thrown. Find the probability. Find the probability. Find the probability, okay, of getting a number, less than or equal to 4. Okay, so again, first of all, so probability is favorable outcomes upon total outcomes. See, what is total outcomes? Total outcome is sample space, number of sample space, right? So it is going to become 6 obviously. Favorable outcomes is cardinality of event A. So event A will be what? Either 1 or 2 or 3 or 4, because equality is right here. So 4. So easy peasy, 4 by 6, which is going to become 2 by 3. Easy peasy lemon squeezy question, right? Basic question, like grade 9 question we have done. Okay, it's 2 by 3. One more question. Okay, one more question says that 4 cards are selected. 4 cards are selected at random. Okay, from a pack of from a pack of 52 cards. Okay, from a pack of 52 cards, and the probability that at least one king is always included, that at least one king is already included. Okay. 4 cards are selected at random from a pack of 52 cards. I hope that you are aware about card terminologies, right? If you are not aware, go watch my permutation and combination lecture. What are you doing? Okay, so the question is saying this: from a pack of 52 cards, the probability that at least one king is included. Okay, so we know that 52 cards are there, out of which 13 fours are 52. So 4 suits are there. Suit number 1 is having 1 king. Suit number 2 is having 1 king. Suit number 3, 1 king. Suit number 4, 1 king. So there are 4 kings. Okay. So I want at least 1 king. So 4C1, I have secured my 1 king with me. Now I need how many cards? This is a PNC based question basically. 4C1, okay, at least 1 card. So 4C1, okay, rather than doing that, because see, remember I told you in permutation and combination is at least 1. Whenever you hear the word at least 1, okay, 4 kings are there, but at least 1 is what? At least 1 is equals to total minus none. Okay, at least 1 is total minus none. Basically, see, at least 1, if I just mark it as event A, none is A complement. Okay, so what I'll be doing is, see, understand, A is the event at least 1. A dash is event none king, no king. So what I'll be doing is I'll be calculating A dash, probability of A dash. Okay, and I know that probability of A plus probability of A dash is 1. I will make use of it. So probability of A dash, that means no king. So out of 52 cards, I don't want any king. I will remove 4 kings. I will get 48. Now 48, I will pick 4 cards of 48 and total 52. C4 is already there. So this is probability of getting no king, but I want at least 1. So this is your at least 1, which is equals to 1 minus, so PA is equals to 1 minus PA dash, that is 48 C4 upon 52 C4. Okay, this is how you have to do it. So if you go and direct find out at least 1, it will take, you have to take cases. At least 1 may, you have to take cases. Acha, or 1, exactly 1 is a king. Exactly 2 are king, exactly 3 are king, exactly 4, all 4 are king. Okay, so rather than taking 4 cases, that is why whenever you see this word at least 1, don't even think about calculating at least 1. Think differently. Okay, like that. Okay, now another question, one more question. Letters of the word regulations, okay, are selected at random. Okay, are selected at random. Find the probability that exactly 4 letters are in between. 4 letters are in between R and E. Again, PNC based problem is right here. How to solve it? Basic. R blank 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 E. Because I want 4 letters in between R and E. Okay. Alright, 1, 2, 3, 4, 5, 6, 11. Total 11 letters are there. If you count, 11 letters are there in regulation. So first of all, we have to make a pack of it. Okay, 11 minus 2, because R and E are specific. 11 minus 2, 9. So now 9 letters are there. I want to insert 4 between R and E out of 9, because R and E are gone. Now see, total 11 is there. 11 minus 2 is 9. Now 9 are remaining. Out of these 9, I want to insert 4 letters. So let us select 9C4, 4 letters. Okay, so now we have 1, 2, 3, 4. This is a pack. Okay, I need 1, 2, 3, 4 to insert between R and E. So 9 minus 4 is 6. Okay, so I need 4. Okay, so favorable outcomes will be again 9C4 into 4 factorial, because we have to shuffle them also. Now this will become one single unit. Okay, they will stay together. So 9C4 into 4 factorial for these 4 letters, and R and E also can change their places, switch, interchange. So 2 factorial. Okay, so this is done. So 9 minus 4, now 6 letters are still remaining. 9 minus 4, 6, yes. 5 letters are still remaining. So 5 are there. 5 plus this will remain 1 unit. I will count as at single letter. Remember Fevicol method. We have to, if we want to keep them together, our 4 letters are there. So this is 1 unit. 5 is there plus 1. So total now 6 letters are there. We need to shuffle them. 6 factorial. This is your favorable outcomes. Now total outcomes will be 11 factorial. Now you arrange it. 9 factorial, 4 factorial, 5 factorial. 4 factorial into 2 into 6 factorial upon 11 factorial. So clearly 4 and 4 are getting cancelled out. This 5 factorial will get cancelled out with 6 factorial. So it will become 6. 11. So if you just try to write it finally, probability will become 9 factorial. So this is 11 is what? 11 into 10 into 9 factorial. And this is 2 6 are 12. Okay. And this is your 9 factorial, which will get cancelled out. So this is your 6, this is your 5. Probability is 6 upon 55 is your final probability of this question. General PNC based question will be there. Okay. Alright, okay. Now we will talk about a PYQ, JEE Main PYQ. Okay, so this is JEE Main 2019, guys. JEE Main 2019 question. Okay, so the question says if 3, let me just write it down. If 3 of the 6 vertices, this is related to a hexagon. If 3 of 6 vertices of a regular hexagon are chosen at random. Then the probability that the triangle formed with these chosen vertices is equilateral. Okay. Alright. Is. The probability is something which we need to figure out. Now understand. If I draw, do we have shapes over here? Do I have shapes? No. Okay. I do have, yeah, no. Yeah. I'll draw it myself. Hexagon looks like this. This is your hexagon. Regular hexagon, okay. Now you should be, if you're not aware, let me make you aware about this cute little hexagon. 3 of the 6 vertices are chosen at random. So obviously total outcomes will be 6C3, randomly chosen. Probability that the triangle formed with these vertices is equilateral. Now you should be aware that there are only 2 equilateral triangles formed by this hexagon. Because of symmetricity, you can also think about it. See, if you pick this and this and this, there will be one triangle you can see. And by symmetry, you can say that this is an equilateral triangle. Ma'am, where is the symmetry? I don't understand. See, you are picking 3 vertices in such a way that there is a gap of first. So first is picked, second is dropped, third is picked, fourth is dropped, fifth is picked, sixth is dropped. So this is a regular like symmetric hexagon. Regular means symmetric hexagon. If you just rotate it, it is everything like first, second, third, fourth, 5, 6, all the vertices are same. The sides are same, the angles are same. The figure is absolutely symmetric everywhere. So this is one triangle and this is another triangle if you are seeing. So only 2 triangles are there. So favorable outcomes are 2. Probability will be 2 upon 6C3. That's it. Easy peasy lemon squeezy question, JEE Main 2019. Now we have again another question which is a like old question, AIEEE 2010, but it is still relevant question. AIEEE, old AIEEE era. Question from AIEEE era 2010. Okay, so an urn, question says an urn contains 9 balls of which 3 are red. 3 are red. Okay, 3 are red, 4 are blue. 4 are blue and 2 are green. Okay, these balls are drawn at random. Without replacement. Okay, from the urn. All right, the probability that 3 balls have different colors. 3 balls have the 3 balls have different colors. Okay, this is your question is. Options are also there: 2 by 7, 1 by 21, 2 by 23 and 1 by 3. Let us understand the problem. An urn contains 9 balls of which 3 are red, 4 are blue. Okay, so 9 balls are there, 3 red are there, 4 blue are there and 2 green are there. Okay, 3 balls are drawn at random without replacement from an urn. The probability that the 3 balls are of different colors. So we want 1 ball of each color. That's it. So now the total outcomes will be 9C3. But the favorable outcomes will be what? 3C1. I have to select 1 red out of 3. 4 out of 4 blue. I have to pick 1 blue and 2C1. So this is your answer, which is what? 3 into, if you solve it, I'm not going to solve it, 2 by 7, option A. Solve it and just comment if you're not getting the correct answer. But if you solve this expression, you will get 2 by 7 at the right. Easy peasy question, okay? One more question, which is NTA's favorite genre. NTA's favorite, okay? I am pretty much confused whether to put this question in determinants chapter or in permutation and combination or probability. So basically, matrices and determinant, they combined with either PNC or probability, and this is the NTA's favorite thing to do. Okay, so the question says entries of a 2 cross 2, and this is NTA's favorite, by the way, plus JEE advanced favorite as well. JEE advanced favorite as well. Okay, entries of a 2 cross 2 determinant. Entries of a 2 cross 2 determinant are chosen from set 0, 1. the probability that the value of determinant is non-zero. The probability that value of determinant is non-zero. Is non-zero, guys. Okay. So now what to do, like how to solve it. So first of all, understand, let us take a determinant A, which is A, B, C, D, and if you solve it, AD minus BC cannot be equal to 0, and the entries could either be 1 or could either be 0. So see, total outcomes you have to calculate. So A has how many options? A can either be 1 or be 0. So 2 options. B has again 2 options, either 1 or 0, either 1 or 0, either 1 or 0. So 16 is total outcomes. Favorable outcomes. Favorable outcomes. Okay. Favorable outcomes are something wherein we can't see. AD minus BC cannot be 0. So understand AD. So we have to take cases. Case number 1. AD. If AD is 1, BC cannot be 1. So BC has to be 0. Are you getting my point? This is case number 1. So AD 1 means A and D both 1. BC 0 means either B is 0 or C is 0 or both are 0. So 3 cases. Okay. So from here B is 0, C is 1. That does also work. B 1, C 0. That will also work. Both 0 will also work. So can you see that AD is 1, only 1 cases, but 3 cases, so total 3 cases from here. Second, now this time, if AD is 0, so that means BC cannot be equals to 0. So BC is 1. Again, how many cases for this? 3 cases for this. So total how many cases are you able to see? 6 cases. So favorable outcome is 6. 6 by 16 is your probability. Okay. So again, this is the problem not for the probability. This is a PNC based probability problem, I would say. So yeah, this is it. One more PYQ I would like to give you, which is JEE Main 2019 PYQ. JEE Main 2019 PYQ. Okay, 2019 PYQ. Okay. Alright. The question says, let S equals to 1, 2, 3 and all the way up to 20. Okay. A subset of B. A subset of B is said to be nice. Is said to be nice. Nice. If sum of elements of B is 203. Of B is 203, right? Then the probability that a randomly chosen subset S is nice. Okay. Now understand the question. Let S is having all the natural numbers, first 20 natural numbers. Okay. A subset of B is said to be nice if sum of element is 203. Now understand. What is the sum of total elements of set S? So total sum, if I just calculate, let us get the idea now. Like how will I get 203? It's a random number. So total sum will give me an idea at least how much deficit I am. Is it too much? Is it very less? So 1 plus 2 plus 3. If I add all the numbers, I will get 20 into 21 by 2. Remember sequence and series formula. So this is 210. That means I am pretty much close to 203. Okay. So see, just if I remove 7 from S, what will I get? I will get a subset which is nice. My one subset will be there. So I am talking about a subset having all the numbers except 7. So if I remove 7, obviously the sum will become 203. So subset will become nice, yes or no? Okay, ma'am. So case number 1, remove 7. So this is one such scenario. Now removing 7 is one thing. Removing 1 and 6 both is also a thing, another subset which is nice. 2 and 5 if I remove, again I'm removing 2 elements, 2 and 5. Then 3 and 4 I will remove, again it will become nice. Are you getting my point? Okay. Now can I just do one thing, 4 comma 2 comma 1 also I can remove, right? 4 comma 2 comma 1 if I remove, 3 elements if I remove, then also it will become nice. So 1 2 3 4 5 sets, 5 subsets I am able to create which are nice. And total how many subsets are there? Okay, if you are given with a set, how many subsets are possible? 2 raised to power cardinality. So first of all, probability will be what? Total number of subsets, total subsets of S, and 5. So favorable outcome is 5. So 5 upon total subsets of S. S is 2 raised to power cardinality. So 2 raised to power 20. So answer is 5 upon 2 raised to power 20. Okay, this is a JEE Main 2019 PYQ. Okay, shall we move on to the next problem? Okay, so many problems we have did overall. Okay, another problem on your screen, the chance that a 13 card combination, okay, from a pack of 52 playing cards, okay, the chance that a 13 card combination from a pack of 52 playing cards is dealt to a player in a game of bridge, okay, in which exactly 9 cards are of same suit, same suit. Now understand, the language is a little bit different. The chance means they are talking about the probability only. The probability that a 13 card combination from a pack of 52 playing card is dealt. So total outcomes, basically what they are saying is they want 13 cards out of 52, wherein so total outcomes will be 52 by 52 C 13. But now they are saying that favorable outcomes may 9 cards are of same suit. So there are 4 suits. See, 52 cards are there. There are 4 suits. 13, 13, 13, 13. Each in each of the 4 suits. Now I have to pick a single suit at least. Okay. If you are saying that ma'am, pick a card from you are saying same suit. So I'll be like, okay, first of all, let me just decide the suit. I have 4 different options. Whether I want to go from diamond or heart or club or spade. So 4 options are there. First of all, I'll be picking my one suit. Suppose I have picked diamond. Okay. Now from this diamond, from these 13 cards, I want my 9 cards from this. Now 9 cards are there. 4 are still remaining because total I want 13, right? Total cards I want 13. So now how many are remaining? So if I just take 52, I have subtracted 9 cards already taken. So 9 are taken, it is going to become 2 and 42, right? 43. Yes, 43. So now 43 cards are remaining. I need my 4 more cards. So this is 40C3, 4. This is your answer. If you are going to solve it, you are 4C1, 13C9. Hold on. Sorry, 9 cards are there. Which 9 cards are of same suit? Okay. Hold on. I have made a mistake over here. It is not gonna be like this. 9 cards are selected, but I want exactly, basically they have not written at least. So which 9 cards are of same suit? So I am assuming exactly 9 cards I want from that suit. Now I don't want any more card from that suit. I have to reject that suit. I don't want any more diamonds. Now I want different. So 13, 30, so now 39 C4. So 4 cards will come from a different suit, which can be either spade or club or your heart. Okay. I hope that this is clear. And let us move on to the next problem of this, which is A and B. A and B. Okay. A and B having equal skill. Having equal skill. A and B having equal skill are playing a game of best of 5 points. Best of 5 points. Okay. Alright. After A has won, okay, 2 points and B has won. After A has won 2 points and B has won 1 point. Okay. The probability that A will win the game is okay. A and B having equal skill are playing a game of best of 5 points. So basically what they are doing is they are playing one game with 5 rounds, basically 5 rounds. Okay, 5 rounds is something which we have already, like, if you play 4 rounds it will not make any sense because there are chances of getting tie. So 3 rounds, 5 rounds will make more sense, because obviously even if you do a tie, like one you are winning, one that is winning, one you are winning, one that is winning. Now 5th round is the decider round. Are you getting my point? B has won 1 point. Okay. Now the game is halfway. Understand the language. After A has won 2 points, B has won 1 point. So see, 5 games will be played and they are already telling you 2 are won by A and the third is won by B. So total 2 points by A, 1 point by B. And now you want that A will win the game. You want A to win the game. Obviously, now the rest 2 will be the decider ones. So there will be 2 cases. 2 cases wherein these 2. So the 4th round, if at all A wins, then we have to stop the game. Because if A wins the 4th round, then even if B wins the 5th round, it doesn't make any sense. A has won because 3 points A have done. Now B, if at all wins, it will still be having at 2 points. So if 4th round has won by A, then we have to stop the game. The second case is that now B has won the 4th round, and now if you want A to win the next round, has to like compulsion. There is a compulsion. It should be won by A. So there are 2 cases. Okay. So probability will be what? Winning of A. Now I want winning of A. Case number 1. I want winning of A. Winning of A can be done by 1 by 2. Equally likely. Equal skilled players are there. B into A. So now I want B to win and I want A to win. So this is 1 by 4. Okay. And we have to add these 2 cases. 1 by 2 plus 1 by 4 is equals to 3 by 4. Now if you are wondering, ma'am, when to multiply, you just multiplied it, you just added it, but when to do it? Understand. Whenever there are 2 cases, like either this or this, A can be won by either 4th round, 4th round is won by A, first case number 1. If not, then otherwise, or is there. Or what we can do is 4th round by B and 5th by A. 2 different cases, there is an or in between, so or means plus. So again, A is half, this is for sure. Now B into A. Now I want 4th round to be won by B and now I want 5th round to be won by A. So and is there, that is by multiplication. Now 1 by 2 and 1 by 4 will be added. This is how it is. Okay. Alright. So one more JEE main PYQ, guys. This will make your probability super duper strong. Okay. JEE main PYQ. Okay. Alright. The probability. This is 2020. The probability that a randomly chosen 5-digit number is made from exactly 2 digits. Okay, is understand the probability that a randomly chosen 5-digit number is made from exactly 2 digits. Now again, this is a PNC based problem. So yes, if I just talk about, first of all, see why I tell you that calculate total outcomes. The moment you will calculate total outcomes now without restriction, obviously. In PNC also, if I will not give you restriction, it is much easy to calculate. If I just tell you that 5 letters, arrange the letters of the word rose for factorial now. So easy will strike in your mind. Now you have warm up your brain. Now you will start understanding with condition how to calculate. So total outcomes, the probability that a randomly chosen 5-digit number is made from exactly 2 digits. 5 numbers are there. 5-digit numbers is there. 2 digits. I have in my maths 10 digits are there. Like decimal 10 I am talking about. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5-digit number if I want to go for, so I want okay, so first of all 0 will come into the picture, so I have to take 2 cases. Case number 1, 0 is there in my digit. Case number 2, 0 is not there in my digit. Now if 0 is not there, I have 9 digits. Okay, so I have 9 digits. Just simply pick 2 digits out of 9, 9C2. Okay, 9C2. Okay, randomly chosen. Oh, sorry guys, sorry, total outcomes will not look like this. Total outcomes may, okay, so there is no condition. I was telling you and I was like, the probability that a randomly chosen 5-digit number is made from exactly, so total outcome is just 5-digit number, random 5-digit number. So obviously first place will not have 0, so you have 10 digits, but you can only place 9. You have only 9 options for the first place. Then the second place is 10, then again 10, then again 10, then again 10. So this is 9 into 10 power 4 is total outcomes. Favorable outcomes will be what? Okay, so favorable outcomes will be randomly chosen 5-digit number is made from exactly 2 digits. Okay, so yes, now favorable outcomes will have a condition. So now you have to again 5-digit, so you have to take 2 cases. Case number 1, that 0 is there. Case number 2, 0 is not there. Okay, if 0 is there, 2 digits you want, exactly 2 digits. You just want 2-digit number. First of all, understand what they are trying to tell you. So 3, 3, 4, 4, 4 is one such number. Only 2 digits you will use. Okay. So if 0 is there, so out of 9, now you want 1. So 9C1, now you have got 1 digit. Okay. So 0 into 9C1 is there. Now first place will be filled by only that other digit. So this is 1. Second place will be filled by either 0 or 9, 2 into 2 into 2 into 2. So this is 2 power 4. But understand, you don't want everything to become that. Suppose you have chosen 0 and 3. So this is of course going to be 3. This cannot be 0. Otherwise this will not become a 5-digit number, right? Now here you are choosing 2 options, either 3 or 0. So what if I choose 3 over here, 3, 3, 3. So basically whatever I counted now, it has also counted one case where all the numbers are 3, which I don't want. Obviously all the numbers cannot be 0 in this case, because first digit I have restricted it. I cannot put it 0. So only one cases will be subtracted. 9 into 2 power 4 is 9 into 15. Now here 0 is not involved. The second case is such that 0 is not involved. If 0 is not involved, then what will happen? You have suppose 3 and 4. So first case is again 2 options, 3 or 4, 3 or 4, 3 or 4, 3 or 4. So this is again 9C2. You have to pick 2 digits. 2 raised to power 5 minus 2, because this time 3 will be a number. 4 will also be a number. So this is it, 9C2, and yes. So this is okay. So finally, if you 9C2 is what? 9 into 8, 72. 72 by 2 is what? 36. And this is 30 into 30. You just have to add these two cases. 9 into 15 plus 36 into 30 upon, it is going to become 9 into 10 power 4. So 9 cancel. Okay, so this is 15 into 4 3s are 15 plus 120 upon 10 power 4. So 135 by 10 power 4 is the answer of JEE PYQ 2020. Okay, alright, okie dokie. So now the next topic will be additional theorem on probability. So for the rest 5 to 10 minutes you'll be like, am I studying probability or am I studying set theory? Because a lot of Venn diagram I'm going to use in this topic. Addition theorem of probability. Okay. Now things are getting pretty serious, huh? Addition theorem of probability. Okay. Alright. Suppose two events are happening, A and B. These are the two events. Okay. So P A union B, probability of A union B will be what? Probability of A plus probability of B minus probability of A intersection B. If I just draw the Venn diagram, you will understand that A union B, so you know what is the shading. So this is your A union B. And this will be equal to probability of A, which is this, plus probability of B, which is this, minus probability of A intersection B, which is this. Now understand how this adding is working. Okay, so this circle is having two things, the left portion of A and the middle of A intersection B basically. This is probability of B, which is having middle plus right portion of B. And you have to, now can you see in here and in here you have added the middle portion twice. So that is why we have to subtract the middle portion once. So now if you just combine the right hand side, you will get P A union B. So this is A union B. This is probability of A, probability of B minus probability of A intersection B. Okay, very easy. Now if A and B are disjoint events. Now remember what are disjoint events? Disjoint, mutually exclusive. Okay, disjoint events. Disjoint events means that there is nothing in common between them. So A intersection B, A intersection B is null. So probability of A intersection B will become 0. Okay, so this is how it is. So probability of, obviously in this case, union B formula will be probability of A plus probability of B. Okay, all right, clear? I hope that this is clear. Now we'll talk about something which is 3 events. This is for 2 events, right? I'm going to talk about A comma B and C. Probability of A union B union C will be probability of A plus probability of B plus probability of C minus probability of A intersection B, probability of B intersection C, probability of C intersection A plus probability of A intersection B intersection C. Okay, so this is again 3 events when 3 events are involved. Okay, so now I'm going to talk about something which will help you in problems. Venn diagram, the proper thing. Now you have to think. Your brain should be active now. Okay, So yes, probability of exactly one of A comma B comma C occurs. Okay, so if I just, and you have to figure out with the help of Venn diagram, I'm not giving you the formula. Okay, exactly A or B or C. Now understand, what do you want? You want this portion, basically exactly one, this portion and this portion. So obviously you are going to write probability of A plus probability of B plus probability of C. Now understand, whenever you have written probability of A, you have included this portion, the A intersection B portion. Okay, so A intersection B portion is right here and A intersection B portion is right here, and you don't want it at all, unlike the previous one. Here you want it at least once, here though you don't want, you have added it twice, so you have to subtract it. So probability of A intersection B subtracted twice. Similarly, probability of B intersection B subtracted twice. Probability of C intersection A subtracted twice. But in this all manipulation, what happened with the middle thing, which is A intersection B intersection C, is this middle thing, right? You don't want exactly one to happen. Exactly one means either this part or this part or this part. No merging. Okay. So probability of A, if you write, that means you have included this middle part, intersection A intersection B intersection C, once plus 1. So plus 1. Probability of B plus 1 plus 1. So 3 times you have added and you have subtracted it. See, this is probability of A intersection B. A intersection B is also having this. So you have subtracted it twice. So you have added that middle portion thrice, 1, 1, 1, and subtracted is 6 times. So plus 3 minus 6. And what do you want? You don't want anything. You want neutral. You don't want this middle portion. Plus 3 minus 6 is minus 3. So overall what you have did is minus 3. So to compensate, to make it neutral, you have to add 3. So probability of A intersection B intersection C. Like this. Okay. Alright. Probability of exactly 1. This is the formula. Obviously, you can remember it. If you can remember it, go ahead. Nothing better than that. But if you forget it, this is the way you have to create it. Okay. Probability of at least 2 of A comma B comma C occurs. Okay. So this is going to become probability of A intersection B plus probability of B intersection C plus probability of C intersection A minus twice probability of A intersection B intersection C. Okay, at least 2. Now understand how we are going to calculate at least 2. So at least 2. First of all, let me just draw it. See, at least 2. Let me draw it right here. Understand. This, and this. Which portion? At least 2 means which portion are you looking for? So at least 2 is this portion, and this portion. So you want the intersection part actually. So clearly A intersection B you want, B intersection C, C intersection A. Now you want the middle part only once, but you have added it thrice. So you have to subtract it twice. So probability of at least 1 will look like this. Then third is probability of exactly 2. Exactly 2. Now exactly 2 means what? That you want which portion? Let me just draw it for you. You don't want the middle portion, right? You just want this, and this. So basically exactly 2 is what? At least 2 minus middle portion. So whatever you have written in at least 2, A intersection B plus B intersection C plus C intersection A minus 3 times P A intersection B intersection C. You have to just remove that middle part once from the previous question, from the previous formula. Okay. So now I guess we are ready for it. We are up for it. Up for a PYQ. JEE Main 2017 PYQ. Main 2017 PYQ. Okay. So the question says, for three events A, B, C, probability of exactly one of A or B occurs is equals to probability of exactly one of B or C occurs is equals to probability of exactly one of C or A occurs, and that is equals to 1 by 4. And so this is the first thing they have given. And second thing, probability of all three events occur simultaneously. Events occur simultaneously is equals to 1 upon 16. And we are looking for probability. Now what they are asking? Probability of at least one of the event occurs. At least one of the event occurs. Okay. All right. Yes. Probability of exactly one of A or B occurs. Exactly one. Okay. So suppose if I draw this, exactly one is either this or this or this. So probability of exactly one will become exactly A or B. Exactly A or B. Correct? That is going to be equal to probability of A plus probability of B minus twice of probability of this middle one, because you have included it twice, you have to exclude it twice. So this is going to become 1 by 4. That is our first equation. Similarly, probability of A plus probability of B minus twice of probability of B intersection C is also 1 by 4. And probability of, this is B and C and B intersection C. C plus A and probability of minus probability of C intersection A is given, which is 1 by 4. 3 equations, 2 and 3. Correct? Probability of all three event occur simultaneously. That means they are giving the overall intersection, that is 1 by 16. At least one, they are asking. At least one means what? Probability of either A or B or C is what they are asking. This is going to become sigma probability of A minus sigma probability of A intersection B plus probability of A intersection B intersection C is what you're looking for. See, let me go back. If I add all three equations, what I get? Probability of A will get added twice. B also twice, C also twice. So I'm going to get probability of A plus B plus C minus probability of A intersection B intersection C intersection A. Because 2 is getting common. Okay, so probability of A intersection B minus probability of B intersection C minus probability of C intersection A, and this is going to become 1 by 4, 1 by 4, 1 by 4, 3 by 4. If you want to cancel this 2 out, so this is 3 by 8. So if I just go ahead and if I just talk about this is coming out as 3 by 8, and they are giving that A intersection B intersection C is 1 by 16. So finally you are going to get 6 by 16 plus 1 by 16 is clearly 7 by 16 is your answer. Very good question. I do like this question a lot. Every I would say in every session I would like to I'll pick this question. Okay, because this is actually a very big question also. Big like that. Okay, so this is a very big question, and it is not that scary also. If you see, it's just that interpretation and just equation solving. Okay. Now let's talk about the conditional probability. So this is again important for your JEE main examination. So yes, conditional probability gives you a formula wherein probability of you have to calculate conditional probability of A given that B has already occurred. Now understand what I'm trying to explain you, because it is quite intuitive. Some students might feel that, oh, this is so tough, what is this notation? The slashes, this is how we read. Probability of A, they are asking probability of A only. Probability of A provided or given that B has already occurred. Now understand. See, given that B has already occurred. Okay. So B has occurred. Total outcomes is what? Probability of B. B has already occurred. Now you're looking for probability A. So can you see that B has occurred? So if I fill the B, and now you're looking for which probability, the numerator will be probability of A where B has already occurred. That means the numerator will be this thing. Just tell me, this is the circle of B. Now just tell me where is this A in this circle. Within this circle you have to find the A. So this is the A within B. This is the A within B. A intersection B is this, right? So probability of A intersection B. So probability of A given that B has already occurred is this. That is one thing. Okay. Also, so yeah, this is the formula. That's it. This is all about conditional probability. Now I'll give you one example to make it understand you a little better, little better. Yes. Okay. So the question is, consider the experiment. 3 fair coins are tossed. 3 coins are tossed. 3 coins are tossed. Okay. This is the thing. 3 coins are tossed. Then E is the event where at least 2 heads appear. At least 2 heads appear. And F is the event first coin shows tail. First coin shows tail. Okay. And you are looking for what? Probability of E given that F has already occurred. So F is something which you have to understand. First coin always showed tail. So the outcomes will be tail, head, head, tail, head, tail, 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 head. Okay. And tail, tail, tail. So 1, 2, 3, 4, 4 outcomes you are having for your this thing. Probability of F. Okay. What about this? At least 2 heads appear. At least 2 heads appear. Now understand, at least 2 head appears. That means, now see, basically what, if I just frame it like this, just understand, probability of at least 2 heads appear given that first coin shows tail. So can you see only this thing is fitting? T, H, H. That's it. So this is 1 by 4. Easy peasy. Okay. Although there is another way of doing it. This is like I to do it this way only. Simple way. Okay. This is the most easy way of doing conditional probability. So I think we'll go with this method. I don't want to confuse you anymore. I just want to go directly. So let us do a couple of questions to understand it better. Yes, one question I would like to give you. Question. Conditional probability. A card is drawn. A card is drawn from a well shuffled. From a well shuffled ordinary pack of 52 playing cards. Okay. The card is drawn and found to be an ace. The card is drawn and found to be spade. Okay. Then the probability that card is drawn an ace. The probability that the probability that card drawn is space. The probability that card drawn is ace. Is. Okay. Understand first of all why is this a conditional probability question. Card is drawn from a well shuffled ordinary rank of 52 cards. The card is drawn and found to be spade. Okay. So probability that a card, probability that the card is ace, given that it is spade. Given that it is spade. Now understand. Total outcomes of being spade is 13, right? Spade is a suit, 13. Now you're looking for a card which is ace, which is a spade. There is only one card, like there are 4 ace. Spade, 1 ace. Club, 1 ace. Diamond and heart, 1 ace. So 1 by 13, easy peasy lemon squeezy, right? Very easy. One more question. And now this will get combined with the set theory again, Venn diagram again. Question says that probability of A is half, probability of B is 1 by 3, probability of A intersection B is 1 by 4, and we are looking for probability of B intersection A intersection. Okay. That means probability of, B complement, given that A complement has already happened. Okay. So that means we are looking for probability of B complement intersection A complement upon probability of A complement. Okay. So this is clearly, see now De Morgan's law. Do you remember De Morgan's law? A complement intersection B complement is what? So if I talk about probability, it is 1 minus probability of A union B That's it. Basically, this is what? See, this is nothing but probability of A union B bar. And A union B bar is this only. So this is 1 minus probability of A union B. And this is 1 minus probability of A. That's it. So 1 minus probability of A union B is 1 minus probability of A. 1 by 2 plus 1 by 3 minus 1 by 4 upon 1 minus B is 1 minus 1 by 2. So if you just solve it, you will get what? So this is 5 by 6. See, 1 minus 5 by 6 plus 1 by 4 upon 1 by 2. So you will get 5 by 6. Overall, you will get 5 by 6. Okay. You do the calculation, you will get the answer. Now is the time for a PYQ of conditional probability. So this is JEE Main 2021 PYQ. Let me just write it down. Okay. So the question says a fair die is tossed. A fair die is tossed. Okay. A fair die is tossed until 6 is obtained. Until 6 is obtained. Okay. Let X be the number. Let X be the number of required tosses. Okay. Then the conditional probability. Probability X greater than or equals to 5, X greater than 2. Conditional probability of X greater than 5 given that X is already greater than 2. Now understand. So this is probability of X greater than or equals to 5 intersection X greater than 2 upon probability of X greater than 2. Direct formula I am applying. Now just think about intersection of, see, X greater than 5, X greater than 2. The intersection will always be X equals to 5 plus X equals to 6 and so on all the way up to infinity upon probability of X greater than 2. So it will start with 3 plus probability of 4 and so on again up to infinity. Okay, fair dice toss until 6 is obtained. X is the required number of tosses. Now understand what we are doing. So here we are requiring what? We are requiring 5 tosses. That means 5th toss is giving me 6 and the first 4 tosses is not giving me 6. Now understand, probability of not getting 6 is 5 by 6 and probability of getting a 6 is 1 by 6. So in here, if I talk about, you are getting 4 times you are getting not 6 and 1 time you are getting 6 plus. Here you are getting 5 times you are not getting 6, 5 by 6 power 5, and 6th time you are getting 6, 1 by 6 and so on. 5 by 6 power, again this is 6 and this is 1 by 6 and so on all the way up to infinity upon. So this is a GP based problem. Upon x equals to 3. So 2 times you are not getting 6, 3rd time you are getting 6. 5 by 6, 3 time and then 4th time you are getting 6. 3 time no 6 and here 4 time no 6 and 1 by 6 and so on. Okay, so if you just try to take, see, 1 by 6 is cancelling out. If you can see, 1 by 6 is coming out of numerator and denominator. So this is at least is gone. And also 5 by 6 whole square you can cancel out. So if you do that, you will get 5 by 6 whole square plus 5 by 6 power 3 and all the way up to infinity. The denominator will become 1 plus 5 by 6 plus 5 by 6 whole square up to infinity. GP of infinite term A, which is 25 by 36 upon 1 minus r, and this is also A upon 1 minus r. So can you see this and this is getting cancelled out? The answer will be 25 by 36 for this question. So again, GP based question are also there in your conditional probability. Okay, clear? Shall I move on to the next thing, which is, by the way, okay, again conditional probability question from a PYQ. So this is PYQ from JEE Main 2019. Okay, 20919. Okay, all right. This, what is this question has to offer? 2 integers. 2 integers, good question. 2 integers are selected at random. 2 integers are selected at random from the set of 1, 2, 3 and all the way up to 11. Okay, first 11 natural numbers, we are selecting 2 integers such that sum of selected number is even, such that sum of selected numbers is even. Can anybody tell me when exactly the sum becomes even? So ma'am, if you add 2 even numbers, for example 2 plus 4, 6 plus 4, like 2 even number will always give you an even number, but 2 odd number will also give you even. So even plus even, if you add, you will get even. Odd plus odd will also get you even, right? And even plus odd will give you odd. So odd you will only get over here. Otherwise, if both are even, you will get even. Both are odd, you will get even. Okay. So such that sum of selected number is even. Now they are looking for the conditional probability that both numbers are even. So basically you are looking for probability that both numbers are even, E plus E, given that the sum is even. Okay, so now understand, sum is even, total outcomes. Tell me when exactly the sum becomes even. So ma'am, either, so see, this 11 numbers are there. Out of these 11 numbers, 6 are odd, right, and 5 are even. 6 are odd and 5 are even. So the denominator will have, so either I want 2 odd. So 2 odd, so 6C2, I have to pick from odd things. So you will get what? Some even will be there. Okay. Or plus sign. what you can do is you can select even numbers, 2 even numbers. So out of 5, because now I have 5 even numbers, I will select 2. And even plus even. Can you see now the probability that both numbers are even? So now the numerator will have only even plus even wala thing. So 5c2. So 5c2 is 10. This is 15 plus 10. This is the answer. So 10 upon 25. 5 2s are 10. 5 5s are 25. 2 by 5 is absolutely correct. Conditional probability. Gone, gone, gone. You must be thinking, ma'am, you are doing this. We are not understanding this. So watch it twice. You will understand it. Okay? I mean, see, sometimes we make the problem very complicated. Sometimes we just look at it. We're just like, oh, ma'am is doing it, ma'am. But I didn't understand it. Okay. I didn't understand. And will sit. I didn't understand. Watch it twice. Watch it thrice. Go have a walk. Come back. Watch it 4th time. And you'll be like, oh, like that. So this happens. The solution is very simple. Problem is complicated. See, as an engineer, if you want to become if you're an aspiring engineer, if you want to become a good engineer, I don't care whether you're studying from IIT, from NIT, or from any college. At the end of the day, I'm just telling you this. Obviously, that if you get into an IIT, it's a big thing, it's a good thing. But at the end of the day, being an IITian or being a non-IITian also, you have to understand that problems in life, mathematics teaches us this only. Problems in life are very difficult. The problem is difficult. Answer is not difficult. The solution is not difficult. So you have to find the easy solution for that. You have to keep things very, very simple. Like in life, this is what I have learned in like previous 5 years. Because see, this the period of like 20, when you become 25 plus, 25 plus to 30, 35, these 10 years you are figuring out that what is happening with me. Life is this, adulting hits you. You'll be like, okay, now I have to understand the life. So I have realized that maths and life are very much together. Maths is also finding a solution to a problem, and life is also like this only. Handling problem, and first of all addressing, acknowledging, okay, I am dull. I have lost it. My brain is not braining. This is the problem. Now how will I work? How will I make my brain braining? Are you understanding it? Okay. So if you just, whenever you feel bad, whenever you feel overwhelmed, first of all acknowledge that, okay, I'm feeling that. This is the problem I'm facing. Okay, let me just go take a walk. Come back. Okay, now what to do? What is the solution? Do you want to feel overwhelmed? Okay, 10 minutes, take it. Cry it out. I have cried also. I have panicked also. Now what? Get back to work. Okay? Chalo. Too much gyan today. Last lecture for the Soror series. Too much gyan session. A die is thrown. Okay, PYQ 2 times. A die is thrown 2 times, and the sum of the scores appearing on the dice is observed to a multiple of 4. Then the conditional probability that the score has appeared at least once. Okay. Alright, this is JEE Main 2020 PYQ. Now understand, let us read the question. A dice is thrown 2 times, and the sum of the scores appearing on the dice is observed to a multiple of 4. Sum is multiple of 4. Conditional probability that score 4 has appeared at least once. Okay. So conditional probability that 4 is there, 4 comma something, like something a, 4 comma a is there. Okay. That the score 4 comma a should be, or a comma 4 should be. Probability that 4 comma something is there, given that sum is multiple of 4k. This is your probability. Okay. So first of all, the denominator, sum is multiple of 4 2 times, 1 comma 3, 3 comma 1. You will get sum is equals to 4. Okay. Then you are having, so these are the two things, comma. You are having 8, sum 8, 6 comma 2, 2 comma 6. Okay. Then 5 comma 3, 3 comma 5. Sum is 8. Right. Then 4 comma 4 obviously will be there, 8. So this is sum 8, sum 12. 6 comma 6 is 12. That's it. Okay. So sum 4 2 comma 2 is also there, right? So yes, 1 2 3 4 5 6 7 8 9. So can you see 9 will be there, and 4 should appear at least once. So I'll select this. So this is only 1 by 9. JEE Main 2020. Tick tick tick, checklist done. Okay. All right. So this is all about conditional probability. Now we will talk about multiplication. See, multiplication theorem on probability. Multiplication theorem on probability. Okay. Alright. So again, multiplication theorem is very easy. Probability of A given that B has already occurred is what? Probability of A intersection B upon B. This is your conditional probability. Now, see, this is your conditional probability. Now, the multiplication theorem on probability is nothing. This is this only. Just you have to multiply probability. So, P A intersection B will be probability of B multiply probability of A intersection B, right? And also probability of A intersection B is also, because see, this is the first formula. If somebody asks you probability of B intersection A, so this is probability of B intersection A. Sorry, I am speaking incorrect. Probability of B given that A has already occurred is equals to B intersection A upon probability of A. I hope that you are understanding the formula. This is B, you have to write it in the denominator. So A intersection B will be probability of A multiply probability of B intersection A. This is multiplication theorem on probability. So we'll directly solve problems on this. Okay, so I have got only one problem on multiplication. Okay, rarely you will see problem on multiplication, but yes, probability you will get. There is no something frequently asked question in probability. Okay, 3 cards are drawn successively. 3 cards are drawn successively without replacement. Okay, from a pack of 52 playing cards. 52 playing cards. The probability that first 2 cards are kings and third card drawn is queen. See, 3 cards are drawn successively without replacement from a pack. The probability that first 2 cards are king and third card is queen. So they are talking about probability of first 2 cards is being king and intersection third card is queen. Okay. Okay, 3 cards are drawn successively. So this is like the multiplication theorem only. So probability of K, K, Q is what they are looking. So probability, 2 cards are king. So how many kings are there? 4 kings. 4 by 52. Correct? Now 1 card without replacement. So throw it away. Throw it in dustbin. Now you are having 51 cards and you are having 3 kings. Now you are having 50 cards because you are throwing it away. But you queen, how many queen are there? Still 4 queen is intact. So this is it. So this is the answer. Okay. So I think conditional probability, multiplication theorem on probability is also done from my. Now we are going to dive into one very important topic, which is independent event. What is an independent event? Understand? Independent event. Independent event. Okay. So independent event, I'll give you an example that what is an independent event and what is not an independent event. Suppose a husband and wife duo is there and they both are applying for a job wherein the vacancies are 2 or more than 2. Okay. So suppose a husband gives an interview, he gets selected. A wife gives an interview, she also can get selected. So selection of husband and wife are independent event. Okay. But if I talk about again another scenario where husband and wife are applying for a job where the vacancy is only for one post. So if husband gets selected, then the selection of wife will be obviously dependent on selection of husband. One of them can only get the seat. So it is a dependent event basically. So independent event, that means, now understand, do not confuse this with disjoint event. Okay, disjoint event is completely different thing. Here in independent event, A intersection B is not null, unlike disjoint event. It's just that they both are independent of each other, right? So the formula for this is independent event PA intersection B. In case of independent event, this is PA multiply PB. Okay, that is first thing you have to understand about the independent event. The next thing we should know about independent event is related to the conditional probability. Remember the conditional probability? Now conditional probability says that probability of A given that B has already occurred is what? PA intersection B upon PB. Yes or no? Now just tell me one thing. That probability of A, if I talk about A and B are two independent events, and now I am asking you that probability of A given that B has already occurred. Now you must be thinking, independent events. And what are you asking now? Probability of A given that B has already occurred. Now ma'am, just tell me one thing. You are asking me probability of A given that B has already occurred. When A and B are independent, how does it matter? How does it matter whether B has occurred or not? In that case of husband and wife, just tell me probability of husband given that wife has been selected. It doesn't matter wife has selected or not. So it is going to be just probability of A only or probability of husband. Right or wrong? See, based on this formula also you will get the same result. Probability of A given that B has already occurred is what? Probability of A intersection B upon probability of B, yes or no? And over here probability of A intersection B, I am not able to write the file. Okay. This is probability of A multiply probability of B, yes, upon probability of B. So B cancels, so you are getting probability of A only, right? So whenever independent event are there, it's just that understand whenever two independent event are there. See, this is again ninja technique. Whenever I see A and B are independent and somebody is talking about conditional probability, what I do is, okay, A and B are independent, so just remove this. Just remove it right away. Okay. So if A and B are independent, just remove this. So probability of A slash B is probability of A only when two are independent. Okay. Now one more thing, if A and B are independent event, if A and B are independent event, then this implies A and B dash is also independent. This implies B dash and A is also independent. This implies A dash and B dash are also independent. Okay. Alright, clear? Alright. Let us now do a JEE main PYQ. Let us do a JEE main PYQ. Okay. Okay, JEE main PYQ. So, JEE main PYQ says that in a box there are 20 cards. In a box there are 20 cards. 20 cards. Okay. Out of which 10 are labeled as A. Out of which 10 are labeled as A, and the remaining 10 are labeled as B. Okay. Cards are drawn at random one after the other with replacement. Cards are drawn at random one after the other at random with replacement. That means we are keeping it back with replacement till a second A card is obtained. Till a second A card, now understand, second A card is obtained. Okay. What are you looking for over here? This is a GP based question. By reading the question, I can tell this is a GP based question. Now, what do you want? Before the third B card, before the third B card, okay, is okay, till a second card is obtained, the probability that the second, okay, hold on, the probability, okay, random one after the other with replacement till a second A card is obtained. Okay, the probability that now they are asking the probability that second A card appear before third B card is obtained. Okay, this is what your question is. Now understand. This is a JEE main PYQ, by the way, 2020. Okay, good question. Okay, so over here, understand that what do we want? We want probability that a second A card appears before third B card is obtained. So there will be multiple cases, we have to think about it. Suppose the best case scenario will be what? That I will just randomly draw a card and it is A. Okay. Second card, then I keep it back, shuffle it. Then I keep it back and I'll just remove one card and I get the second A card. So now we are like, this is the case which we wanted, because see what is happening over here. If you can see that before the third B card I have obtained it, before even the first B card I have obtained. So this is one of the case. Next thing which can happen over there is that if I just pick a card, first card is A, second is B, and again I'm going to get this. The moment I get second A card, I have to stop. Okay, and before the third B card. Okay, this is also one of the case. Plus probability of what if I get B, A, this is also a case. Plus what if I get probability of now A, if I get, it's fine. If I get AB, it's fine. If I get BA, it's fine. Now need to get BB. Now third cannot be B. Before the third, if I third is B, this is not my case. So this is BBA. Okay. BBAA, sorry. BBAA, right? plus this is probability of now B A B A Baba. Okay, plus this is probability of A B B A. That's it. All the cases covered. Nothing else apart from this you will be able to think. Now probability of A is what? Half, because 10 are A, 10 are B. Probability of A is half, probability of A is half. So independent events probability will get multiplied. Half into half. Independent, how come ma'am you are seeing that these are independent? Because see, you have taken out A, kept it. Now taking out B, taking out A, all these are independent, because if you have kept it again, you have kept it back. If you have not kept it back, then the scenario would be a little bit different. Then the first card if you have taken out, then you are having 19 cards. Then the probability will be different. But you are keeping it back now. So that is why probabilities are same and independent. Plus half, half, half. So half cube plus half cube again. Okay. Plus 1 by 2 power 4 plus 1 by 2 power 4 plus 1 by 2 power 4. So can you see this is becoming what? 1 by 4. See, what are you getting? 1 by 4 plus these two things. Okay. This is what? 2 by 8. So 1 by 4 again. Okay. Plus what is this? 3 by 16. So 3 by 16. This is what you are getting. This is 11 by 16 will be your answer to this question. 11 by 16. Okay. So this is how it is. Independent event question, JEE Main 2020. Okay. One more question. Let's do one more question. Okay. Again a PYQ question. Alright. Independent event maybe I have a lot of questions to do. Question. Again a big question. Okay. Just shift this. Come forward. Okay. In a game. In a game. Two players, A and B. Two players, A and B, take turns. Okay. Two players, A and B, take turns in throwing a pair. In throwing a pair. In throwing a pair of fair dice. In throwing a pair of fair dice, starting with player A. Starting with player A. Okay. And total, starting with player A and total of the scores on the two dice. And total of the scores of two dice in each throw is noted. Okay. A wins the game if he throws 6 before B. A wins the game if he throws a total of 6 before B throws a total of 7. Okay. And B wins the game. So this is how A wins. How about B wins? B wins the game. B wins the game. Okay. B wins the game if he throws a total of 7. If he throws a total of 7. A total of 7. Okay. A total of 7 before A throws a total of 6. Before A throws a total of 6. Okay. Alright. The game stops as soon as either player wins. The game stops. The game stops as soon as as either player wins. Find the probability of A winning the game, P of A, okay? And this is JEE Main 2020 PYQ, by the way. Good question, big question. It took me a while to write this question, but again GP type of question. Previously that question was not GP type, but this is a GP type of question. Let us understand. In a game, two players A and B take turns throwing a pair of dice. So player A throws a dice, and if he is getting total of 6, okay, then he wins. Before obviously B, okay. So what we want is, in the beginning only, like one time only, I want that first time A starts the game and he wins. Probability, right? So what will happen? Probability that A is winning, okay, plus. Now what we can do is, now probability of B losing, right, winning A. So losing B and then A winning, okay. So like basically also A starts the game. If he throws a total, wait, A starts a game. Yes, so A is starting the game. So we want that if A is losing, failure of A, then I want my B also to fail. Then I want my A to win. Plus, next time, again, if A fails, then I want my B to fail. B fail A, then fail B, okay. Then one more time, if A fail, I make sure that we want to fail B, and then my A wins, and it will go all the way up to infinity. Now understand, you have to calculate the probability of winning of A. So probability of A winning the game will be what? Probability of A winning the game will be, see, 2 dice are being thrown, so they are independent. Probability of winning the game will be 6 square 36, and now you want the total of what? Total of 6. So total of 6. Basically you want probability of winning A. So total of 6 you will get, or more than total of 6. Basically you don't want to get, see, total of 6, how will you get? Tell me. Total of 6. So total of 6, 1, 5, 5, 1. Okay. Then you have 3, 3 also, 4, 2, 2, 4. These are the values he should get. So 5 upon 36 is probability of A winning. Probability of A losing will be what? Tell me. Remaining 31 by 36, correct? 31 by 36. And same, probability of B failing will be what? Now probability of B winning, so total of 7 we want, right? So probability of B winning. So for B to win, we want total of 7. Now tell me, 6, 1, 1, 6. Ma'am, 3, 4, 4, 3, 5, 2, 2, 5. So how many cases? 6 cases. 6 by 36. So 1 by 6. What about the failing? Probability of B failing is 5 by 6. Now just place all the values. Place all the values, okay? You remember all the values? Just place it. It's frustrating. Why my pen is not working today? Probability of A winning the game. So clear cut, it is 5 by 36 and clear. Probability of B failing, 31 upon 36. Okay, B failing will be 1 by 6. Then A winning, 5 by 6. Right? Plus this time A failing will be 31 by 36. Okay. B failing will be 1 by 6. Okay. A failing again 31 by 36. Then B failing again 1 by 6. Then finally I want my A to win 5 by 36. So are you understanding that in each, see, This is an infinite GP whose first term is this. What about the common ratio? So common ratio mein this 31 by 36 into 6 is getting multiplied everywhere. See, this and this was already previous term. Can you see this factor is getting multiplied? This is your common ratio. So you just have to write probability is nothing but, probability is nothing but a upon 1 minus 5 by 36 upon 1 minus 31 by 36 into 6. So this is 36 into 6. This is your final probability of this question, okay? Took me a while to solve the question because of the, I don't know, my file is like, I'm writing since a lot of time. Maybe the file is a little bit heavy, so it is getting stuck. Alright, now what do you think? Shall I do one more question? One more question on independent event. Okay. Alright, so the one more question on independent event says if A and B are independent events, okay, and PA intersection B is equals to 1 by 6, okay, PA bar, that means A complement is given to you, which is 2 by 3. They are talking about 6P PB, given that A has already occurred. Now A and B are independent event. Now ninja technique, shortcut. Remove A. A and B are independent. Remove B. So this is 6P of B directly. You just have to write 6P of B, right? So now P of B, how to calculate? How will you calculate? Just understand. This is A intersection B. Independent hai. So this is PA into PB. And this is 1 by 6. From here, if PA is 2 by 3, so PA bar is 2 by 3. So PA will be what? Complement 1 by 3. So this is 1 by 3 into PB is 1 by 6. Okay. So this is 1 by 2. PB is coming out as 1 by 2. So clearly 6 into 1 by 2. 3 is the correct answer of this easy peasy question. Because of this amazing independent event, just the denominator is gone, no value. Okay. So this is how independent event works. Alright. Okay. One more question, which is, by the way, your JEE main PYQ. This is 2020 PYQ. Let me write it down. Okay. I think I have a problem with my charging. That is why this pen is not working. Let me just do a little bit. Let me just keep it on charging and see whether my thing is working fine or not. Okay. Let us check. Let A and B are two independent event. Question. Oh yes, see. Let A and B. See, these are the technical issues. You don't even know. I mean, if I just keep my laptop on charging and I write, it is smooth. If I just remove it, it is not smooth. Okay? I mean, who will tell me? Let A and B be two independent events. See what is happening? Independent events. Such that it is not easy to become a teacher. I mean, it is easy to become just a teacher. But it is not easy to like do all this by yourself, setting up the studio, figuring out the technical issue. The small issues will come and you'll be like, just because of that issue, whole thing is collapsing. I'm not able to take lectures. Just one solution, simple solution, keep it on charging and you'll be like, oh, nice. A and B be two independent events such that P of A is 1 by 3 and P of B is 1 by 6. Okay. Then which of the following is true? JEE Main 2020 PYQ. Option A is P A complement / B complement is equals to 1 by 3. Option B, easy question. P A / B is 2 by 3. C, P A / A union B is 1 by 4. Okay, again I'm facing this issue. Wait, let me do this question and understand what is happening. 1 by 3. Okay. Alright, A and B, two independent events. So I have already told you now, this denominator is of no significance. So this is actually talking about probability of A bar. Okay, so probability of A bar is 2 by 3. So this is incorrect. Because probability from here now, probability of A is 1 by 3. Probability of A bar is 2 by 3. Incorrect. This is again probability of A. This is correct. Huh? Option B is correct. Can you see? Sorry. Yes. This is correct. Probability. Option B seems to be correct. Okay. And this, what is this? This is again, can you see this denominator? A union B is of no use. Probability of A, which should be 2 by 3. So this is also incorrect. And this is again probability of A, which should be 2 by 3, but given as 1 by 3. This is also incorrect. Option B is easy peasy question. Correct. Okay. So, and this is one last question on independent event. And yes, here we go. Again a PYQ. 2019. Okay, the question says 4 persons can hit a target. Okay, 4 persons can hit a target correctly. You must be thinking, ma'am, your handwriting sometimes feels it's a different thing. Sometimes you write it differently. Like in previous page, if I go back, see, this is also my handwriting. This is also my handwriting. Okay. I mean, it depends on me. If I want to write it nicely, I can do that. So 4 persons can hit a target correctly with probabilities 1 by 2, 1 by 3, very good question, 1 by 4 and 1 by 8, okay, respectively. Okay. If all hit at the target, independently, okay, then the probability that the target would be a hit, that a target would be a hit is, okay, options are 25 by 192, option B 25 by 32, option C 7 by 32, and option D 1 by 192. Okay. Alright. So very easy solution for this question. This is a very typical question. Like you will see this question in each and every book of JEE Main. Every book, R.D. Sharma, every book will have this type of question. Very popular question. Since so many years, I am doing this question. More than 10 years I am doing this question. Okay. So none of a target would be a hit. 4 persons are hitting target. Okay. All the probabilities are given. If all hit at the target independently, events are independent. If at all it is not given, then also understand this is an independent event question. Then the probability a target would be a hit. So the style to do it, the technique to do this question, required probability is 1 minus no one can hit the target, or the target is not hit. 1 minus none can hit the target. So none can hit the target means 1 minus probability of A bar, probability of B bar, probability of C bar, probability of D bar. This is the way to do this question. Okay. So the answer will be 1 minus A bar is 1 by 2, B bar is 2 by 3, C bar is 3 by 4, and this is 7 by 8. So the answer would be 25 by 32 if you solve it, which is matching with option B, 25 by 32. Okay. Alright. Clear? Now we will talk about total probability theorem. Why am I talking like this? So now we will talk about total probability theorem. Now understand what I'm trying to tell you. Total probability theorem. Okay, I'll be writing a formula, a very scary formula. Okay, and then I'll make it easy. Scary alert. Okay, so you are having this Venn diagram wherein a set A is there. Okay, and you are having a set B. Okay, and set B is, so see, this is your set B and this is your set A. There are two sets. Okay, now set B has been broken down into so many small events. Okay, let me just break it like this. This is B1, this area is B1, this area is B2, the complete area, then B3, and so on all the way up to the last is Bn. So the agenda is to have, see, B1 is having some chunk of A, B2 is having some chunk of A, B3 is having some chunk of A, Bn is also having some chunk of A. Then only it will make sense. Okay, so this is how it is. Now if you're looking for probability of A, it is going to become probability of B1, probability of A provided B1 has already occurred, plus probability of B2, probability of A provided B2 has already occurred, and so on all the way up to probability of Bn given that, into probability of A given that Bn has already occurred. Now understand what is happening. Okay, probability of, now how did it came, ma'am? What is this? What are you writing? Just tell me one thing. Probability of A intersection B is what, ma'am? Probability of A union B upon probability of B, correct? Okay, so if I just cross multiply, and if I just, already we have studied probability of multiplication theorem. Okay, so if you multiply PB into, see, PB into PA slash B is what? Intersection. This is what? This is nothing but A intersection B1 plus probability of A intersection B2 plus and so on probability of A intersection Bn. Now just Venn diagram will tell you whether this right hand side is giving you probability of A or not. So can you see A intersection, A is circle and B1 is this. So probability of A intersection B1 is this. Probability of A intersection B2 is this. Probability of A intersection B3 is this. Probability of A intersection B4. Probability of A intersection Bn is this. Now A intersection B1 will be replaced by PB into PA slash B. PB2 into PA slash B, and so on all the way up to infinity. Okay, all the way up to n. So this is your total probability theorem. Now this theorem, you will be like, okay ma'am, we are getting the theorem, but when you solve a problem, now let us take a PYQ, it is completely different from what, I mean, the formula is same, the idea is same, but the theory part and the application part are completely different. It is not that okay ma'am, we understood theory, now we will definitely be able to do the problem. Problem application is completely different idea. Same goes in base theorem as well. Base theorem, after this we are going to study base theorem only, very important. So same goes in base theorem. If I tell you the theory, you will understand theory, okay, good. But problem solving is something which is done in a slightly different trick. There is some trick involved. Okay, so PYQ 2019, let me just write a big question in probabilities, right? But yeah, an unbiased, okay, unbiased coin is tossed. Unbiased coin is tossed. Okay, if the outcome, okay, this is PYQ. If the outcome is head, then a pair of unbiased die, a pair of unbiased die is rolled. Okay, is rolled, and the sum of numbers and sum on them is noted. On them, on both the dice is noted. Okay. So basically what are you doing is you're tossing a coin. If it is head, rolling a pair of dice, noting the sum. Now if it is a tail, okay, if the toss, now understand, if the toss is tail, then a peck, then a card from well shuffled pack of 9 cards is drawn, is randomly picked or is drawn, okay, is picked, numbered, numbering is also done, numbered 1 to 9, okay, and the number is noted, okay. Basically the probability questions are, that is why a little bit on like lengthier side, because they wanted to tell you the story, okay. The probability that, now we need to find the probability that number is either 7 or 8, either 7 or 8. Now understand what is happening. Coin is there, it will give you head. If it gives you head, then what you are doing is rolling a dice. So 7 or 8 sum, how will you get? Tell me. So after head you have to roll a dice, 7 or 8. So 1, 6, 6, 1. Okay. 2, 4, sorry, 2, 5, 5, 2. Okay, 1, 2, 3. Then 3, 4, 4, 3. Now 8. 8 is 4, 4. We'll start with 4, 4. 3, 5, 5, 3. Okay. Then 2, 6, 6, 2. Okay, and so on. So this is your head. Now if you get tail will be, now if you get tail, you should be having just 7 and just 8. Okay, so 2 cases are here. So probability will be what? If you get a head, half, then your probability will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so your answer will be 11 by 36. Or if you get a tail, again probability of getting tail is half, and then 7 or 8 getting is 2 by 9. So you just have to solve it and get the answer. So your answer will be 19 by 72 is the correct answer. Okay. So this is the total probability theorem. Although the theory was completely different, now when the question comes, automatically you will think like this. Okay. Now we will talk about Bayes theorem, the final section of this Bayes theorem. Bayes theorem. Okay. What is the Bayes theorem? So Bayes theorem, I will not teach you theory. Yes, I'm not going to do that. I'm directly jumping onto the problems because theory will freak you out. Okay. So, yeah. So a pack of cards is counted with face downwards. A pack of cards is counted with face downwards. With face downwards. Okay, with face downwards. It is found that one card is missing. That one card is missing. Okay, one card is drawn. One card is drawn and is found to be red. And it is found to be red. Okay, alright. The probability that missing card is also red. The probability that missing card is also red. Missing card also red. Now understand first of all how to identify that this is a Bayes theorem problem. What is the specific details given in Bayes theorem? a scenario will be given to you and there will be a line which is talking about something which has already happened. Okay. So can you see something is happening, pack of card facing downward, it's found that one card is missing, one card is drawn and it is found to be red. This is the line. Something has already happened. Okay, and now they will talk about the next probability. Something is already done. Something is done and dusted. Okay. So pack of cards is counted with face downwards. Okay, 52 cards. Okay, 52 cards wala hi hai ye. So now you're having this thing that the question is, a pack of cards is counted with face downwards. It is found that one card is missing. Okay. One card is drawn and it is found to be red. Okay. So see, this statement is telling something has already happened. That means this is a clear-cut case of Bayes' theorem. Now we have to figure out the probability the missing card is also red. So you're looking for probability missing card is red. See, probability missing card is red. Okay. Given that card drawn is red. Card drawn. What is fixed? What is already encountered, discovered, that card is drawn and it is found is red. Card drawn is red. This is what you're looking for. First thing. Okay. So Bayes' theorem says that you just have to write the favorable probability upon total probability. Okay. I will give you the formula, but the formula will be quite confusing. So remember this, favorable probability upon total probability. Total probability. What is total probability? So total probability is something, so there are two cases, right? There are two cases. So this is a case number 1 and case number 2. Case number 1 says that missing card can be red. See, what is fixed? That card drawn is red. It is not fixed that missing card is red. We are looking for the probability. It can be missing, it cannot be missing. Missing is red is one case. Okay. Missing is not red is another case. Missing not red is another case. Okay. Now just tell me, two scenarios are there. You have 52 cards. If missing is red, then what is the scenario? You have 51 cards, which will have 25. If missing is red, so usually 52 cards are there. 26, but missing card is 25 red plus 26 black in this scenario. Right or wrong? Yes. And here 51, but this time reverse. 26 red plus 25 black. Okay. What is the favorable case? Tell me, this is your favorable case. And now in the denominator, total probability. Right. So your answer will be, total probability will be what? So first of all, step by step we'll do. What we will do is, we'll first of all understand that there is a card missing. Okay, 52 cards are there. There is a card missing. Now probability of missing is red and missing is black is half. Because see, right now if you have 52 cards, okay, equal cards are there. If you want one card to go missing, equal probability, so half. So total probability I am trying to write over here. Total probability, I have less space. This is going to be half. Okay, let me write it here only, right? Missing a red. Yeah, it is better if I write it. Probability of this will be what? Half. Missing is red. Multiply. Missing is red, you have decided. Now you're looking for card drawn is red. Now you have to draw a card. So you want to draw red card. So 25 by 51. And here probability will be what? 1 by 2 again. This time again you want to draw card is red only. But this time missing is black. So card is red. So 26 by 51. This is your missing is red, missing is not red. Now Bayes' theorem says that probability of event C, probability, what are we looking for? Missing is red, card drawn is red. Yeah. Missing is red / card drawn is red. Card drawn is red. Okay, first question you will face a little bit trouble, but second question onwards will be pro. So denominator we have to write the total probability half 25 upon 51 plus half. 26 upon 51. And numerator will have what? Missing card is red. This is red. This is not red. So this will have numerator, will have the chunk of numerator. Like some part of denominator will be written down in numerator. This is your final half, half. Now just calculate. Half, half, half cancel out. 51, 51, 51 cancel out. 25 upon 51 will be the correct answer. Okay. 25 by 51. Okay. One more question on base theorem so that you get the better understanding of it. Okay. I have with me. Let us take a PYQ. Okay. Box I contain 30 cards. Box I contain 30 cards. Okay, 30 cards numbered from 1 to 30. Numbered from 1 to 30. Okay, 1 to 30. And box 2 contain. And box 2 contain. Box 2 contain 20 cards. 20 cards. Okay. 20 cards. Numbered 31 to 15. Numbered 31 to 50. 1 to 20 in one box, 31 to 15 another box. Okay. A box is selected at random. A box is selected at random. Okay. Box is selected at random and a card is drawn from it. And a card is drawn from it. Okay. Then the number of card is found to be a non-prime number. The number on card is found to be a prime number. Did you notice I wrote this with a different color? Because something has happened. Card is drawn. It is found to be a prime number. Something has already fixed. It is fixed. Okay. Now we are looking for again similar. Can you see the similarity between question number 1 and 2 also? The probability that card was drawn from box 1. The probability that card was drawn from box 1 is, this is a PYQ 2020. Okay, shall we do this? Alright. Okay. Alright, so yes. Now again, probability, you are looking for probability that card is from box 1. Card from box 1, given that number is prime. Number is prime. This is what you're looking for. Okay. So see, this is fixed. Card is from box 1 is not fixed. So again, I'll take two cases. Two cases. That card is from box 1, card from 1, card from 2. Same scenario, you have to do it repeat telecast. Card from 2, card from 1, card from 2. Correct? Now card from 1. So again, just tell me that what are the prime numbers in box number 1? 2. Then we have 3, 5, 7, 11, 12, 13, 14, 15, 16, 17, 19. Okay. Card from 2. So card from 2, how many prime numbers? You can see in card 31, 37, then 41, 43, 47. Okay. Alright. So now probability, I'm going to write it. See, if I pick, what is happening? You are drawing a card actually. That's it you're doing, right? So you are drawing a card. Drawing a card from box number 1. So probability will be what? half into, now how many total outcomes from here? 20. 1, 2, 3, 4, 5, 6, 7, 8. 8 by 20. This is half multiply 1, 2, 3, 4, 5. 5 upon 30, right? 30 to 50. See, sorry, this is 30. And we have more primes. Sorry, 19 ke baad we have 23 and 29. I forgot. I thought first card is having 20. No. First box is having 30. Next is having 20. So this is 8, 9, 10. 10 by 30, right? 10 by 30. And this is 5 upon 20. So your probability based theorem says write down the total probability in the denominator. So half into what? How many numbers? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Okay. How many prime numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are there, right? Let me just go back to the question and check it out. Okay, be a prime. Okay, fine. Yeah, it's fine. So half into 10 by 30. Right? I was writing the denominator. Half into 10 by 30 plus half into, okay, 1, 2, 3, 4, 5. 5 by 30. 5 by 30. And you're looking for card coming from box 1. So favorable outcome, you have to write it over here. So now just you have to cancel it out. Half getting cancelled out. This is 10 upon 30. 30 also can 10 upon 10 plus 15. 10 upon 10 plus 15 is 25. 10 by 25. So 5 2s are 5 5s are 2 by 5 is the correct answer. Yes. This is 20, correct? This is not. Yeah. So now your answer will be just calculated. 0 0 cancel 0. Hold on, not like this. Cancel 0 from here. This is 20. Half cancel. 0 0 0 cancel. So this is 10 upon 3 upon. This is what? 10 by 3. So 6. 3 2s are 6. Can I take? 20 plus 15. 20 plus 15 will be 45, correct? So yes, 3 1s are 3. 3 2s are 6. 2 will go upstairs. So 20 by 45. So your answer will become what? 5. Have I done any mistake over here? No, I think this is fine. 20 by 45. 5 4s are and 5 9s are. Okay. 4 by 9. 4s are 25, 9s are 45. 4 by 9. Is it correct? Just have a look at the calculation part. Yeah, I think it's correct. Okay. So yes, this was the question and the last question for the base theorem. Okay. Yes, last but very good question. Big question for the base theorem. I'm scared. How will I write? My pen is not working today. Okay. Anyway, big question. The last question. Don't worry. A child answers a multiple. A child answers multiple choice question. I will write shortcut. MCQ of 4 alternatives. Okay, of 4 alternatives. So what is happening over here? A child is writing, answering in MCQ. Okay, 4 MCQ. Basically, just like your JEE in MCQ. No, 4 options are there. 1 question is written. Okay, having 1 correct option, just like JEE, not JEE Advanced. Having 1 correct option. So having 1 correct option. Okay, having 1 correct option. The child either knows, now understand, the child either knows the answer. It happens. You guys are JEE Pro expert giving mock test regularly. Okay, the child either knows, okay, or he can copy as well. If he doesn't know, he will copy. Okay, or if at all he doesn't get chance of cheating, so he will do, okay, let me guess the answer. 3 options are available. Either know, okay, guess the answer. Now probability that he knows the answer is 1 by 2. Probability that he copies it is 1 by 6, and probability that he guesses the answer is 1 by 3. Okay, is 1 by 3. Now, the probability of child knowing the answer, okay, the question saying the probability of child knowing the answer the probability of child knowing the answer, if answer given by him is found to be correct, okay, is, okay. Also it is known that if he copies the answer, then the answer is correct with probability 1 by 8. It is given that if he copies, if at all he copies, if he copies the answer, okay, copies the answer, then the answer is correct, with probability 1 by 8. Okay, now understand. Child is answering MCQ is there. Child either know or copy or guess the answer. Knowing the answer is 1 by 2. Copying is 1 by 6. Guessing is 1 by 3. So there are actually 3 cases. The probability child knowing the answer if answer given by him is found to be correct. Now understand. Found to be correct. The language, Bayes theorem. So we want probability of child knowing the answer given that it is correct. This is what we are looking for. So denominator it will have total probability, right? So there are 3 cases. Understand, cases are 3. First case, he knows the answer. If he knows the answer, probability of knowing answer is 1 by 2. I am calculating the probability 1 by 2. Okay, probability that he knows the answer is 1 by 2. Okay, and you know that answer is correct. Okay, so no probability that he knows the answer and it is correct. So obviously if he knows, that means it's correct only, na? So he knows the answer, okay, and it's correct. Case number 1, he copies the answer. Probability that he copies the answer is 1 by 6, and as per the question C, it is given. If he copies the answer, then the answer is correct is 1 by 8. So he copies it is 1 by 6, and now copy can be correct or incorrect. So we are looking for only the correct option, so 8. This is for sure. And if he guesses it, the probability of guessing is what? 1 by 3. Probability of guessing is 1 by 3. Okay. And now if he guesses, just you tell me, MCQ is there, I am guessing, I am thinking, okay, maybe C is correct. What are the chances that it is correct? It is 1 by 4. It is not given, but it is 1 by 4. This is something which is quite intuitive, huh? This is something which is interesting in this question. This part is not given, that you have to figure out. Now the question says that then the probability of child knowing the answer, if answer knowing the answer. Now you're looking for knowing the answer. So probability will be what? Total probability. I'm going to write in denominator. So 1 by 2 into 1. And this also was a surprise. Like if he knows it, definitely it would be correct. So you have to think. Plus 1 by 6 into 1 by 8. Okay, plus 1 by 3 into 1 by 4. Okay, and the numerator will have what? Only the knowing probability, half into 1. This is your answer. If you solve it, what are you getting? 24 by 29. And on this note, the probability chapter is done. Last session of the road series with so many hurdles today. Okay, so many not, but yeah, by the end pen was not working fine. I don't know what happened with my system. Yes, so now I'll be seeing you in the next series, which is it is not just a problem solving series, hashtag. Not just a problem solving series, not just a problem solving series. You will see a lot of insights in that series, not just a problem solving series. Okay, all right. Now on this note, I'll wind up today's session, and I'm gonna meet you super soon in the next series. Bye bye.